check, check. Online students, you can hear me clearly, right? Online students. Okay, thank you. Check, check. Okay. There were some questions. There are some questions online. I'll answer them too. Yeah. I'll answer the online questions too. Okay. Please be seated, everyone. Be seated quickly. Everyone, be seated quickly. Yeah, there's a question and I should correct that actually. Uh, Last week when we were discussing Newton's first law, uh, check what you wrote there. Okay. There we should apply external unbalanced, the term external unbalanced force. We should apply the term, we should write the term external unbalanced force. That term should be included, okay? Do that correction on your like Newton's first law. It should be an external unbalanced force. Yeah, and some students mention about their first term test. Okay, just let me know. Okay, just let me know. Like, up to what point are you going to get the first term test? Okay, up to what point are you going to get for the first term test? And like, when would you have the first term test? Okay, just mention that. I can try to support that through extra classes or something like that. I'll like provide all the messages again when the class starts properly. Okay. Uh, you already know this content, okay? You already know this content, so we can try these questions. Go to exercise 2. Go to exercise 2. question 1, question 4, question 1, question 4, and question 7. This is related to Newton's second law, but we already know a version of Newton's second law. Okay, we already know a version of Newton's second law, which is F equals ma, right? We already know one version of Newton's second law, which is F equals ma. So you can try these questions. Okay, so you can try these questions. Let's start with these questions because let's start with the things that we already know. And who are the students who don't have tutes? Who are the students who need tutes? Anyone? Anyone? Raise your hand if you need the tute. Marlon, provide the tute in the Zoom chat too. Tute will be available in the Zoom chat too, but many tutes have been delivered already, okay? Okay, some would get, yeah. Just when you're writing about your term test, write up to what point are you going to get for the term test and when would you have the term test. I can put some, I can arrange some online sessions and cover those remaining parts quickly for the students who are having the term test, okay? I can do something like that. Let's start with these questions. Quickly try these questions. And 9. You can try all these questions from O-level knowledge, okay? You can try all these questions from your O-level knowledge. So just apply F equals ma. Let's start with the things that we already know, okay? Let's start with the things that we already know before writing Newton's second law. This is not the actual Newton's second law. We would learn that, but for now you can use this. Overall force acting on an object. Overall force acting on an object. This should be the overall force or else the equivalent force. Overall force or the equivalent force acting on an object equals ma, okay? Do try these questions. Mali, can you put the tutes in the Zoom chat? And for online students, or if you are someone's joining from another platform, just send a message to this number to receive the tutes, okay? Not 701546825. Not 701546825. Just send a message to this number. Not 701546825. Send a message to this number requesting for the tutes. I mean, for now, you request for the PDF if you don't have the tute. Then just send a message and we will deliver you the tutes, okay? And I hope a lot of students have, you already have the tutes delivered, I think. You don't have to worry, okay? Anyways, we will teach this area, okay? We will teach this area, but for now, you can find the overall force. Can you remember we learned the concept called equivalent force, right? Equivalent force. Equivalent force is the overall force acting on an object. That means if you have 5 newtons, if you have 2 newtons, and if you have 3 newtons, equivalent force is the vector sum of these forces, okay? If you have 5, 2, and 3 newtons, equivalent force is the vector sum of these forces. Just get the vector sum and apply F equals ma to find the acceleration, okay? Find the acceleration. That's all I need you to do at the moment, Okay. Find the vector sum and apply F equals ma to find the acceleration. quickly do finish the questions. Okay. So from the theory that you already know, you can do these questions. Okay. We should check your number. Okay. Uh, question 1, exercise 2. Question 1. Many questions are simple. An object of mass 4 kilogram is at rest. A force of 20 Newton acts horizontally on the object. What is the acceleration? So apply F equals ma. F equals ma. Force is 20 newtons. Force is 20 newtons. Mass is 4 kilograms. And acceleration is a, which results in an acceleration of 5 meters per second squared. Then question 4. An object of mass 2 kilogram is placed on a smooth horizontal plane. A force of 4 Newton acts in the direction of figure. What is the acceleration of the object along x and y axis? So we have a 2 kilogram mass here. 2 kilogram. 2 kilogram mass here. And a force of 4 Newton acts on this. Force of 4 Newton acts on this. And this angle is 30. So they need us to find what is happening in x direction and what is happening in y direction separately. They need us to find what is happening in x direction and what is happening in y direction separately. Okay. So what we can do is, pay attention. What we can do is, I can resolve the vector into two directions. I can resolve the vector into two directions. This is 4 cos 30. This component is 4 cos 30. 4 cos 30. This component is 4 cos 30. Because when you go through the angle, it is 4 cos 30. This is 4 sine 30. 4 sine 30. So 4 cos 30 means 4 cos 30 means 4 cos 30 means root 3 over 2. 4 sine 30 means 4 into half. 4 into half. This gives you 2 root 3. This gives you 2 root 3. Here you get 2. Here you get 2. So now on this object, on this 2 kilogram object, you have a horizontal force of 4 cos 30. You have a horizontal force of 4 cos 30, which is 2 root 3, and a vertical force of 4 sine 30, which means 2. Then I can apply F equals ma. To this. F equals ma. I can apply F equals ma. So they are asking separate accelerations in x direction and y direction. So to find the acceleration in x direction, you should use the force in x direction. So find the acceleration in y direction, you should use the force in y direction. So the force in x direction is 2 root 3. Force in x direction is 2 root 3. 2 root 3. The mass is 2 kilograms. And horizontal acceleration, that means the acceleration in x direction, I would take as ax. This gives me 2 and 2 cancels out. Ax is root 3 meters per second squared. Then in y direction, force is 2, F is 2, and mass is again 2 kilogram, and I'll take this acceleration as AY. Then AY would be, when you solve this, AY would be 1 meters per second squared. So that's why we learn how to resolve vectors, okay? That's why we learn how to resolve vectors. We first resolve vectors in x direction and y direction. Then we find the acceleration components in those directions. Like last row people, you can hear me, right? Last rows? Yes? Yep. Mali, can hear me clearly, right? Okay. Yes, yes, you have that option too. You can find the overall acceleration, then resolve the acceleration too. Okay, it gives the same answer. You find the overall acceleration, then resolve the acceleration into two directions. And again, last Friday I discussed 2017 paper, 2017 term test paper, Ananda College. Tomorrow, I'm not sure whether I'm capable of doing that. If not, I'll be doing a session on Monday or Tuesday. So anyways, at least 1 or 2 days per week, I'll try to discuss term test papers, okay? So I'll go to, I'll shift between different schools, and I'll try to discuss at least 1 or 2 term test papers per week. But the thing is, I can't like inform all the sessions like 5-6 days before, okay? I just, whenever I don't have meetings or anything else in my company, like whenever I find like 3-4 hours or at least 1 or 2 hours, then I'll inform in the group and I'll quickly do the discussion. So for me, it's difficult to inform before the session, okay? I won't be able to inform a lot before the session. I would quickly notify in the group and do the term test discussion, but anyways, you would always get the recording. So you can watch the recording if you miss the session, okay? You have that option, because even tomorrow I'm not sure whether I'm capable of discussing a term test paper. If not, I'll be discussing it on maybe Saturday or Sunday or or the next coming Tuesday, something like that, okay? Question 7. Question 7. Did everyone get the revision tute and all? Revision tute? Revision tutes? I'll discuss one more question and move to the second Newton's law, okay? Question 7. Question 7. So if the mass of the object is, 25 kilograms, if the forces are 650 and 750, forces are 650 and 750, forces are 650 and 750, and 200 and 200 and 200. Question is, find the acceleration. Find the acceleration. So in a question like this, okay, in a question like this 200 newtons is useless, right? In a question like this 200 newtons is useless, right? Why? What is the reason? I mean, the total force cancel out, right? Why? We are applying the force in downward direction. You can't do anything in downward direction because you have the flow. Okay. So this 200 newtons is useless, right? So although we apply the resultant force in this equation, we should figure out there are some forces that are useless. Okay. That are useless. We tell that this is axis of freedom. Pay attention, everyone. Pay attention. We may call this the axis of freedom. That means although you have a lot of forces on this object, this is in this axis, it is not free, right? In this axis, it is not free. It can't move. So there's no point of applying a force in a direction where you don't have an axis of freedom. Clear? In this direction, object is not free to move. Clear? So what matters is this force and this force, right? So again, I can write F equals ma in horizontal direction. Then the horizontal force is 750 minus 650. Why? These forces are in opposite direction. So this is 750 minus 650 equals mass is 25, and acceleration is a. Mass is 25 and acceleration is a. 750 minus 650 equals 25 a. Then the acceleration is 750 minus 650 means 100. You divide it by 25, which means 4 meters per second squared. 4 meters per second squared. This is the acceleration. So let's move to the second Newton's law, because this is not the actual representation of Newton's law. This is what you know from all levels, right? This is only one version of Newton's law, okay? This is only one version of Newton's law, okay? Go to your note, and there should be a small correction. Last week, I explained this when I was explaining, but I didn't include it in the definition, in the English definition. Newton's first law, you should correct it as unless an external unbalanced force acts on it. What I mentioned was unless a resultant force acts on it, right? It should be corrected as unless an external unbalanced force acts on it. It's better. That definition is better. That's why. Every body continues to be in a state of rest or to move with a uniform velocity unless an external unbalanced force. Unless an external unbalanced force acts on it. Unless an external unbalanced force acts on it. Okay? Should be corrected as unless an external unbalanced force acts on it. Then go to write Newton's second law. Write Newton's second law. That's what we were applying in these questions, okay? The rate of change of momentum of a body, Newton's second law, the rate of change of momentum on a body, the rate of change of momentum on a body rate of change of momentum of a body is proportional to the rate of change of momentum of a body is proportional to the resultant force acting on that direction. Is proportional to the resultant force acting on that direction. The rate of change of momentum of a body is proportional to the resultant force acting on that direction. Newton's second law. Okay. The rate of change of momentum of a body is proportional to the resultant force acting on that direction. So what is the meaning of this? What is the meaning of this? And last week I asked you to write these things in a book or a paper, right? And did I mention how should you organize your notes? No. Like how should you choose whether you are going to write it on a paper or the book? Yes or no? No. No? I mean, what? I mean, last week I asked you to like take a piece of paper, write. I mean, we are going to write only these laws. Okay, that's all for the whole lesson. What we would be writing is the Newton's laws. The reason for me to ask you to write that, pay attention, because like you have to write it at least once to remember it. Okay. But I asked you to choose whether you are going to write it on a paper or the book and do what is suitable for you. So when you are like taking decisions, you may feel like this is a very small thing that I'm mentioning, but this is something really important. Okay, this is something really important. We are not writing notes to revise today or not to revise tomorrow, not to revise for the first term test. Okay, we are writing notes to revise things when it is like 2-3 weeks for the A-level exam or 1 month for the A-level exam. Okay, so when you organize all your notes, keep that in your mind. When it is 1 month to the exam, there's a lot of rush. You have to do a lot of things. There may be different issues. Okay, some subjects you may struggle in some subjects. Then you have to have a very good plan. You have to like go through everything. 2.5 years of content. You have to write it in a 3-hour paper. Okay, so it's a lot to do when it is close to the exam. Okay. So when you are preparing your notes in all 3 subjects, keep that in mind. These notes should be accessible, really convenient when it is only 1 month for the exam. That means if you have everything in your tute and if you have a very small content in your book, then you have to return to the book. Okay. It is okay for the first term test because you don't have a lot of content, but when these kind of stuff feels for 2.5 years, then it's a lot. You have to shift between the book, the tute, maybe a piece of paper, like that. Okay. Assume, take our papers. We give you a paper every week. So assume you have the paper somewhere and you write the answers for that in a book, and the answer scripts provided us by us are in the like maybe in the WhatsApp group. Okay. Now these papers would be useless when it is close to the exams. Why? You can't revise anything, right? They will be really useful because now it will help you to develop your ability to do questions. But you can't revise them when it is close to exams. Why? You have a book, you have a bunch of papers, and you have answer script somewhere else. Okay. So what I would do is I would get the paper and write everything in a piece of paper and staple it to the paper. And I maybe every day I would download the answer scripts provided in the group and put them in a separate drive. Now to revise papers, I'm talking about 2.5 years of papers. Okay, see how many papers? A huge pile of papers. Now I have a pile of papers, but I don't have a book for that. I have the answer script with the paper. And I mean your answer script, the things that you wrote in the discussion. And you have everything properly numbered in the in your drive folder. Now it's convenient, right? Now the paper is useful. Why? You can quickly revise. But again, You don't have, if you have to revise all the 15 questions of all the papers, then it is again useless. So if I were you, what I would do is I would highlight the most important or most difficult or things that I made mistakes or the careless mistakes. I would highlight those numbers, or I would circle those numbers in a different color. Now when it is close to exams, what I'm going to do is I'm only going to go through those questions. So it will be 2-3 questions per paper. Now again the paper is useless. Now again the paper is useful, okay? But if you don't have anything organized like that, you don't know what are the important questions and what are the questions that are not important. So you just have to go through all the 15 questions, again useless. Why? When it is 1 or 2 months for the exam, you don't have time to do something at that scale, okay? If it is only three questions per paper that you have to go through, it's really convenient. If it is 15 questions, are not convenient. See? Okay? And like, I mean, these are now you are getting tutes, okay? If you get the heat tute, okay? If you get the heat tute, okay? These tutes are not tutes, okay? These are books, okay? You would get like 8-9 tutes like this, okay? It's 94 pages, okay? It's 90, yeah, it's 94 pages, okay? So again, this tute is really, I mean, I give perfect notes for everything because like it saves time, otherwise we had to write everything. But again, this book will be useless if it is like this. Why? When it is 1 month for the exam, how are you going to read something like this? Okay? But if you have this tute, colored properly, underlined properly, highlighted the important facts, then it is, when it is 1 month for the exam, this book is really convenient. Why? You have all the facts organized in one book. Okay? You have used maybe sticky notes or something, and you have properly organized only one book. So when you need to revise it, what you do is you just go through the highlighted parts. Then again, this is useful. If it is like this, it's just a book, which is really useless when it is close to exams. Why? How are you going to read something like this? It's huge. Okay, and you have like 8-10 books, okay, by then, when it is close to exams. So in all three subjects, okay, in all three subjects, when you're, and like you may be really, like you may be really intelligent or not, I don't know, whoever the person, okay, whoever the person, they would struggle when it is close to exams to revise theory content. Why? It's 2.5 years of content. It's a lot of content. And it's for 3 subjects, okay? It's for 3 subjects, okay? So if your notes are not well organized, you are in a huge trouble when it is close to exams, and you can't prepare a note when it is close to exams. There's no point of getting a note from your friend. Why? It's his or her tute or not, which includes what they find hard, not what you find hard. Okay, so that your friend's tute would be useless. Okay, so then you are in trouble. How can you revise content? We don't think about these things. We only realize these things when it is only 2 months for the exams. But then it's too late to recover anything. Okay, it's too late to recover anything. Okay, so that's why I'm asking you, in all 3 subjects, when you are preparing your notes, keep that in mind. These tutes or notes will be useful only when it is 1 or 2 months for the exam. If these tutes are not really convenient, if these are not well organized, every content, every tute you have, every paper you have would be useless when it is close to the exam, okay? So organize things properly, keeping this thing in your mind, okay? Keeping that in mind, your mind. That is, you are going to revise everything only when it is 1 month to the exam, to the A-level exam, okay? So all the tutes or notes should be prepared keeping that in mind, okay? Okay, you may have a perfect note scattered in 2-3 books, but another person may have a note which is not that organized, but it's only in one book, well organized, only in that book. So it's convenient, see? So don't break things into parts, okay? Just don't have the papers separately, answer scripts separately. Even when you finish your term test paper, okay, have a file, write down the questions that you missed, okay? Then write the answers again. Then circle the questions that you find hard after the term test. and especially for the circled questions, write answers in a paper and bind it to that paper and put it into a file that you place everything to be revised before the exam. Now, even in your from your first term test paper, you will have a tute, maybe 3 questions circled. That's all. Okay, you don't have time to go through the whole paper. Now you have a paper, you have circled 3 questions. You are going to go through those 3 questions only. See, make things convenient. Okay, make things convenient like that. Okay. Okay, that's what you have to think when it is close to exams. Why I'm mentioning things now? I mean, there's no point of mentioning these things when it is 2 months to the exam, right? Okay, everything should be mentioned now, and all these things you would realize when it is close to the exam only. At the moment, some may think that yes, this is useful. Some may think no, I would anyways revise somehow. Then we can see, like, when it is close to the exams, people running here and there asking for a note. We get a lot of messages asking for a note. Okay, then we send the note, but it is useless, right? I have a note, not a customized note. I have a tute, that's all, a huge PDF. Okay, if someone asks me for a tute for heat, what I do is I send the PDF of that tute, 94 pages. Not useful, right? When it is 1 month for the exam, you can go through 94 pages. Clear? Okay. So Newton's first law. The rate of change of momentum is proportional to the force acting on that direction. Okay. So I mean to get the actual Newton's law, what you have to do is, you can't do this. What you have to do is, now from the definition you see, force equals rate of change of momentum, right? Force equals rate of change of momentum. So ideally what you should do is you differentiate MV, okay? You differentiate MV, okay? Which we can't do at the moment, and definitely which we can't do in the physics syllabus, okay? So, I mean, if someday or someone knows differentiation, this is the original Newton's law, M dV over dt plus V dm over dt. This is the original Newton's law, okay, which is useless in our syllabus. This is the original Newton's law. You would got to know this when it is maths people would got to know, will like learn this a bit when you are doing differentiation. But for now, let's create a more physics definition, okay, which is, pay attention, F is proportional to, pay attention, stop talking, F is proportional to the rate of change of momentum. That means momentum difference over time, right? Momentum difference over time. That means final momentum minus initial momentum over time, right? F is, force is proportional to the final momentum minus initial momentum over time, okay? Then that's what they mention in the original definition, right? F equals change in momentum over time. Then I would use, you can write this with me, okay? Under the definition, you can write this with me. Then I can use K, then I can use K as the proportionality constant here to remove the proportionality. P2 minus P1 over time, P2 minus P1 over time, F equals K, P2 minus P1 over time. Then I can write K, P2 is final momentum. I would write it as M2V2. Momentum is MV, so I would write this as M2V2 minus M1V1 over time, M2V2 minus M1V1 over time, M2V2 minus M1V1 over time. Then I would measure, you can write this with me. Then if I measure M2 in kilograms, sorry, if I measure the mass in kilograms, if I measure the velocity in meters per second, if I measure the time in seconds, and if I measure the force in newtons, then K will be 1. Then the proportionality constant will be 1. Then only the proportionality constant will be 1. K will be 1 if the mass is measured in kilograms, velocity is measured in meters per second, time is measured in seconds, force is measured in newtons, then only K will be 1. Then only K will be 1. The reason for me to teach all these simple proofs, because you have to know how to do the proof properly. Okay, because I mean I faced the same issue when I was doing A levels. Like they asked us to prove the something called the Biot law, which is a magnetic law, and it is an experimental law in a way, but it has a nice mathematical background, but it was an experimental law. So I mean, like, so I took like around 1.5 or 2 pages to prove that. Okay, I did everything that I know, and I went through a very nice proof for that. Okay, in my A level paper. Okay, to prove the Biot law. But in the marking scheme, the proof was, uh, I mean, F is proportional to I, F is inversely proportional to L squared, F is proportional to sine theta. So as a result, and there's something else, F is proportional to I and sine theta over L squared. Then the proportionality constant is this, and this is the law. Okay, that was the proof in A level. So sometimes, I mean, sometimes we get confused even for small proofs, because we don't know what to do. And so the best thing is I knew how to prove that. That was the worst thing. So I just went through like 2 pages proving. I mean, I had nothing to do. So I mean, you could finish. I mean, if you work properly, you could finish the A level paper within like 3 hour paper within like 1.5 or 2 hours. Okay, for sure. If you work properly, every year like around 1-2% of the students, these are the students who go for higher ranks, would be easily finishing the paper within 1.5 or 2 hours. Okay, because we every year we have many students who do 2 additional questions, 3 additional questions. Okay, it's not a difficult thing when it comes to A levels, because the person who's working would work forever properly. The person who's going to miss stuff would miss everything for 2.5 years. So this gap only keeps increasing. So the good students in A levels and the bad students in A levels, between them, there's a huge gap. There's a huge gap. That means there's a set of students who are not able to even finish two. You have to do 4 essay questions. There's a bunch of students who are not able to finish even 2 questions in the paper. And there's a bunch of students who finish those 4 questions and do like 3 additional questions. There's a huge gap between students because it's a 2.5 years of accumulation. Okay, so the people who do work properly, they accumulate good stuff for 2.5 years, so they keep going in the better direction. And there's others going in the other way for 2.5 years continuously. Okay, so the gap gets widened. So you would see when it is close to A levels, there's a huge gap between the good students and bad students in A levels. Okay, there's a huge gap. Some people are not able to finish 2 questions. Some people do like 8 questions only because they didn't have anything to do. Okay, I mean, there's a lot of examples like that. Okay, so you would see. Okay, now you would laugh, but now you would see when it is close to exams, this actually happens. Okay, you would have a friend who find doing model papers useless anymore because he or she always get 100 marks. You would see people like that. Okay, so we have to learn. Okay, we have to learn the proof of all the definitions properly, because sometimes we choose a longer path for the proof, or sometimes we don't know the proof. Okay, that's why now I teach all the proofs properly. So just learn. Even the simple proofs like this, we have to learn. Okay. Okay. So now, if k is 1, I can write F equals M2 V2 minus M1 V1 over T Now we have two variations of this Newton's laws, okay? Write this down. We have two variations of this Newton's laws. What are they? You have two variations of this Newton's law. One is when m is constant, m constant. Other one is when v is constant. We have two variations of Newton's laws. One is m constant, another one is v constant. Okay, m constant and v constant. When m constant, you can write f equals m is constant. So m v2 minus m v1 over t, which means m v2 minus v1 over t, m v2 minus v1 over t, which means m. What is velocity difference over time? What is velocity difference over time? Acceleration, right? Velocity difference over time is acceleration, right? Change in velocity over time is acceleration. So this is F equals ma. That is what we know from all levels. This is only a one side of the Newton's law, okay? This is only one side of Newton's law. Then let's choose this side. Let's choose this side. When V is constant, F equals m2v minus m1v over t. Then I can write, now V is constant, I would take V out. Then I have m2 minus m1 over t. We don't have a special term for this. This is V delta m over t. This is rate of change of mass. Rate of change of mass. Clear? So in our syllabus, this is not the actual story, okay? In actual story, we have to go through a differentiation. But since we don't have differentiation in physics syllabus, which is fascinating, what we can do is we can go through these two definitions separately, okay? We can use these two definitions separately. One is F equals ma. Another one is V into m2 minus m1 over t. That means change of mass over time. Change of mass over time, which means delta m over t, which means rate of change of mass. Clear? Which means rate of change of mass. Ideally, I have to do more questions from exercise 2 at the moment. Yeah, let's. Now go to exercise 2. Finish writing this. Go to exercise 2. Again, go to exercise 2. Now you can try the correct version. Question 2. Question 3. Now just don't write F equals ma. Now you know, right? Now just directly don't write F equals ma. Now you know that there are two versions. There's a fundamental definition. Now you know everything properly. So you just don't use F equals ma directly. And question 5. Question 2, 3, and 5. Question 2, 3, and 5. And I'll give another question. There's a conveyor belt. There's a conveyor belt moving with a velocity of 5 meters per second. Moving with a velocity of 5 meters per second. We add sand or something, okay, maybe bags to this system with a rate of 5 kilograms per second. We apply bags to this system with a rate of 5 kilograms per second, and the velocity of the conveyor belt is meters per second. What should be the force applied by the motors of the conveyor belt? What should be the force applied by the motors of the conveyor belt? And I would give another question. Another question. Try this question too. There's an electronic balance. There's an electronic balance here. Uh, we release 5 kilogram balls onto this every second. We release 1 kilogram balls onto this every second. Clear? So every second. From a height of 5 meters. From a height of 5 meters. Wait, I'll try to give you an answer that. Oh, let's take 5. No big issue. But 2a is into 10 into, or else let's take 20 meters. 20 meters. What would be the reading? Pay attention. What would be the reading? In the, let's take 10th second. What would be the reading on this balance on the 10th second? I'm not sure whether we can go with a very nice answer for this or not, but we'll try. We'll try. Yeah, give me the reading at 10 second. Clear? Give me the reading at 10 second. Half AT squared. Yeah, this is possible. Give me the reading at 10 second. Clear? I'll repeat. This is an electronic balance. Pay attention. This is an electronic balance. We release a 5 kilogram ball onto this every second. Pay attention. We release a 5 kilogram ball onto this every second from a height of 20 meters. Give me the reading of this electronic balance on 10th second. Clear? Give me the reading on 10th second. Quickly do write the questions. Quickly do write all the questions. And others try to finish this, and whenever you have time, try to finish the revision tutor, okay? And who got the answer for today's last question of the paper? Who got answers for the last question of the paper, 15th question of the paper? Anyone? Yeah, I saw a few answers. Yeah. Okay, cool. Just needed to know that. Okay. I'll start with question 2. When an object of mass 2 kilogram was moving with a velocity of 4, the velocity of the object increased to 12 in 0.5 seconds due to the horizontal force acting on the object. What is the force acting on the object? So it's a 2 kilogram object. It's 2 kilograms. 2 kilogram. Moves with the velocity 10. Moves with the velocity 10. And it increases to 12. Sorry, moves with the velocity 4, right? Sorry. Moves with the velocity 4. Moves with the velocity 4. Then it increases to 12. It increases to 12. Increases to 12. What is the force acting on the object? So again, F equals MA. I can use this version without any issue. Why? Mass is not changing. Mass is not changing. I can use F equals MA. So mass is 2 kilogram and acceleration is 12 minus 4. 12 minus 4 over time is 0.2 seconds. Velocity changes from 4 to 12. Velocity changes from 4 to 12 in, 0.5 seconds. It changes from 4 to 12 in 0.5 seconds. Velocity goes from 4 to 12 in 0.5 seconds. So what is the force? So this is the acceleration, change in velocity over time. So what is the answer? 2 here, 8 over 0.5, which means 32 newtons. 32 newtons. Because 0.5 equals half. Then this 2 comes up. So 2 into 2 into 8 is 32 newtons. Force is 32 newtons. Next, question 3. Question 3. And like, when will you, like, would you have any like holidays recently? Yes or no? Ah, you have A levels. Now all levels for, are you gonna get a holiday? For A levels, yes, right? Yes. Okay. I mean, just like I would do few sessions to cover up some maybe later lessons, maybe one full lesson. Because I mean, then we can add more questions to the paper. Maybe a lesson like optics, something like that. If I have like 2, 3 additional days, I would try to finish another additional lesson so that we can have more questions and more variation of questions on the paper. Okay, let's try to do that. Just let me know when your holidays start, when it's going to end. Okay. Three. Question 3. Question 3. An object of mass 2 kilogram moves with the, so you're gonna get holidays of, I think, 2 weeks of holidays for A-levels, right? One month. Really? So we can finish like 10 lessons then. Okay. Because I mean, even I have nothing to do because 25 batch is over. Usually we give our maximum effort to the final batch. So these days there's a lot of sessions going for 25 batch. Some things to revise, paper classes, paper discussions, practical discussions. There's a lot of stuff going for 25 batch and everything will be over when A-level starts. So I have plenty of time, which means you have a lot of sessions. I mean, it's good to learn, right? Otherwise, you're not going to do anything useful at home for 2 months or 1 month. An object of mass 2 kilogram moves with a velocity of 10, and hits the wall perpendicularly, and rebounds with the same velocity. Velocity is 10 meters per second. 10 meters per second. Collision is for 0.2 seconds. Collision is for 0.2 seconds. Collision is for 0.2 seconds. What is the force exerted by the wall on the object? Pay attention. Okay, let's do it this way. Stop talking, everyone. Pay attention. Pay attention. Okay. So, force equals delta mv over t. Rate of change of momentum. Delta mv over t. Change in momentum over time. Now, these are vector equations, okay? F equals ma, F equals delta mv over t, everything is a vector equation, right? So it's better to choose a direction. In some questions, I don't choose a direction because it's obvious, right? In this, everything is moving in this direction, so the direction is this, okay? And for this, I would choose this as the direction. Okay? So, force equals change in momentum over time. Pay attention. Force equals change in momentum over time. That means final momentum minus initial momentum. What is the final momentum? Final momentum is 2 into 10. 2 into 10. Final momentum is 2 into 10. Minus initial momentum is 2 into minus 10. 2 into minus 10. Initial momentum is 2 into minus 10. Middle rows, pay attention. 2 into 10 minus 2 into minus 10. 2 into minus 10. Why minus 10? This is my direction. This is the direction of the velocity. Opposite. So it should be minus 10. What is the time of collision? Time of collision is 0.2 seconds. Time of collision is 0.2 seconds. Time of collision is 0.2 seconds. So what do I get? Here 20. Here minus minus plus 20 over 0.2 over 0.2, which means 40 over 0.2 multiply by 10, which means 400 over 2 multiply by 10, both up and down multiply by 10. So 400 over 2, which means 200 newtons. 200 newtons. Force equals rate of change of momentum. Force equals rate of change of momentum. quickly do finish the other questions and the questions given in the board. Okay. Next question, question 5. A vehicle of mass 2000 kilogram moving along a horizontal road produces a forward force of 25,000 newtons from its engine. If an external force of 1000 newtons is applied against the motion of the vehicle, what is the acceleration of the vehicle? So just apply F equals ma. Question 5. Apply F equals ma. There's a vehicle. Stop talking, everyone. There's a vehicle. Forces are 25,000 and 10,000. There's a force of 25,000 produced by the engine and 10,000 produced 10,000 produced by the maybe air drag or some kind of external forces, right? Things like friction, air drag, and the mass is 2000 kilogram. Mass is 2000 kilogram. So in this direction, forces are 25,000 minus 10,000 equals mass, which is 2000, mass 2000, acceleration A. Acceleration A. Then I'm going to get A equals 25,000 minus 10,000 over 2,000. 25,000 minus 10,000 over 2,000. Twenty-five thousand minus 10,000 minus 10,000 over 2,000, which means 15,000 over 2,000. 15,000 over 2,000, which means 7.5 meters per second squared. 7.5 meters per second squared. Seven point five meters per second squared. Then the next question. Anyone writing this? Anyone? Done, right? Anyone writing this? No. Okay, this one, pay attention. Here the velocity is not changing. Stop talking, everyone. Here the velocity is not changing. Mass is changing, right? So F equals V delta M over delta T. F equals V delta M over delta T. Clear? Because the velocity is constant, mass is changing. So the velocity is 5. Velocity is 5 and rate of change of mass is 5 kilograms per second. Rate of change of mass is 5 kilograms per second. It is 5 into rate of change of mass is 5 kilograms per second, which means 25 newtons. Velocity is 5. Rate of change of mass is 5 kilograms per second, which means 25 newtons. Pay attention. For this question, I'll give a small hint. Everyone, for this question, I'll give a small hint. Usually, an electronic balance, what it shows is the weight it feels, right? Okay, weight it feels. But now, in this scenario, there's a bunch of marbles filled in this, and additionally, there's a marble coming and colliding with this, right? At the 10th second. So at 10 seconds, there's a bunch of marbles filled in the balance, and there's one marble coming and colliding with the balance, right? At 10th second, that marble would create an additional force more than its weight. Clear? Why now we release these marbles, right? Now it's filled with some marbles, and on the 10th second, there's a marble that come and collide with this. Clear? Collide with this. That collision creates an additional force. So due to that collision, the reading would change a bit. I need you to consider everything. Okay, I need you to consider everything. Students who are done with that, try to finish exercise 2. Others, try this question. I'll give like 5 more minutes. Okay, use that concept. Others, try to finish exercise 2. Revision tutor is given in the WhatsApp group. Given in the revision tutor is provided in the Zoom chat. And put the revision tutor in the WhatsApp groups too. Okay. Pay attention. And I know some videos of some revision tutors are left to provide. I mean, the people who are doing the videos sent to me. I didn't have time to upload that, so I'll quickly provide everything. So this one, we may have to use motion equations. We may have to use some motion equations for this. Pay attention, everyone. Pay attention. So, like, yes, I know we are only going to calculate. We are only going to calculate an average for the 10th second. Okay. Pay attention. Stop talking, everyone. We are going to calculate an average around 10 second. Okay. That's what I can do in this question. I can't give an exact answer. Okay. I can't give an exact answer. I can give an average around 10 second. That's what I'm going to do. So first, let's find the time it takes to reach here. S equals ut plus half at squared. S equals ut plus half at squared. So this distance is 20 meters. This distance is 20 meters. This gap is 20 meters. Starting velocity 0. Starting velocity 0 plus half acceleration 10, acceleration 10, downward acceleration is gravitational acceleration 10, t squared. So this 0 and this 0 cancels out. So t squared equals 4, which means 2 squared. Then t is 2 seconds. T is 2 seconds. It takes 2 seconds, okay? It takes 2 seconds for one ball to reach here, okay? So, pay attention. At 10th second, I'm just giving an average, okay? I can't come up with a very nice answer for this. What I need you to actually find is the reading at 10 plus delta t second. What I actually need you to find is the value shown here at t plus delta t second. That means something like this, okay? Something like this. That means after 10 seconds, okay, 7 balls have already reached this one, okay? 7 balls have already reached here, and the eighth one, oh, is it 8 or 9? We release at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We release 1 at 0th second. Okay. So what do we get when we count from 0 to 10? 11, right? If we count from 0 to 10, we get 11 digits, right? That also we should think. I start at the beginning, right? So these are the most difficult areas for me, counting kind of stuff. So we release a ball at 0th second. Like that, now we keep releasing. Okay. We release a ball at 0th second, first, second, third, third, fourth, fifth, sixth, seventh, eighth, ninth, 10. Pay attention. And it takes 2 seconds for a ball to reach the balance, right? So this guy would reach the balance at after 2 seconds, right? It takes 2 seconds for a ball to reach the balance. This guy at 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Clear? So every ball takes 2 seconds to reach the balance. Okay? So at 10th second, okay? At 10th second, all these balls have previously reached the balance and now they are stationary, right? By the 10th second, all these balls have reached the balance. Now they have stopped and they are stationary. And at the 10th second, this 8th ball collide with the balance, right? It collides with the balance, right? Clear? At 10th second, this 8th ball, it collides with the balance, right? Okay. So this guy, it collides with the balance. Is that clear? It collides with the balance. Now, here this is 1, 2, 3, 4, 5, 6, 7, 8. It's already 8 balls. What is the mass of one? 5 kilogram. So you already have, so you already have So you already have 8 balls in this pan. That means 8 into one ball is, pay attention, one ball is 5 kilograms. That means 50 newtons, right? One ball is 5 kilograms. That means 50 newtons. Clear? So it is 8 into 50. That means 400 newtons. So there's already, pay attention, there's already 400 newtons. Clear? 400 newtons. And as I mentioned, I need an average answer around 10th second, okay? Average answer around 10th second, okay? Okay, pay attention. So it's 400. Now, at 10th second, there would be a ball reaching this, right? At 10 second, a ball would reach here with a velocity of what? Pay attention. V squared equals u squared plus 2as downward. So what is the velocity here? V squared, starting velocity 0 plus 2, acceleration 10, gravitational acceleration, height 20. Height 20. So this gives 20 squared equals V squared, then V equals 20. V equals 20 seconds. Sorry, V equals 20 meters per second. V equals 20 meters per second. Clear? Then this guy collides and create an additional force, right? It collides and create an additional force. So, uh, when it collides, okay, when it collides, what would be the momentum difference of this guy? What would be the momentum difference of this guy? Okay, is it clear up to this point? Okay, okay, write down this part. First, write down this part. You just find the time, you just find the velocity, and already 8 balls have reached the balance, and now there's one ball colliding with the balance. Okay, that's what we have to think. Finish this part. First, write down this part, properly understand and write down this part, and just let me know if you need me to explain this again. Why did I took 8 here? Pay attention. Why did I took 8 here? Because I release a ball at 0th second too. So 0, 1, 2, 3, 4, 5, 6, 7 means 8. 1, 2, 3, 4, 5, 6, 7, 8, right? I release a ball at 0th second too. So if you count from 0 to 7, you get 8 numbers, okay? Now the last part. Quickly finish. Anyone writing this? Anyone? Quickly to finish writing? Quickly, quickly. Let's finish the question. Okay. Sorry? Okay. I'll explain things again. Okay. Now, I mean, we need one more additional data to find that collision, right? We need one more additional information to find the collision, right? Time for the collision, right? Yeah. Let's take time for the collision as 0.2 seconds then. Take time for the collision as 0.2 seconds. Time for the collision as not 0.2, 0.01 seconds. Take time for the collision as 0.01 seconds. That means it stops at 0.01 seconds. It stops at 0.01 seconds. Okay, pay attention, everyone. I mean, using a question, I just needed you to explain a scenario because I have seen a lot of term test questions like this. Okay, so you may get this kind of a scenario in a term test. That's why. Okay, now everyone done writing? Everyone? Yes. Okay. Pay attention. Now this eighth guy, it come and collides here, right? So what happens is it, so mass is 5 kilograms, right? Pay attention. Mass is 5 kilograms, right? And what is the weight? 50, right? If the mass is 5, weight is 50, right? 5 into 10 mg. Weight is 50 mg. And what happens is it reached the balance with a velocity of 20. Now somehow it has to be stationary, right? Somehow it has to be stationary. It should be stopped. So time taken for this process, time it takes to go from 20 meters per second to 0. Time for the collision to end, I asked you to take it as 0.01 second. So time for the collision is 0.01 seconds. 0.01 seconds is the time for the collision. Okay. So what would be the additional force? Now, who stops this guy? Who stops this guy? There's a spring in the balance. There's a spring in the electronic balance. That spring creates an upward force, right? How do we stop this? How do we stop this? There's a spring in the electronic balance. That spring creates an upward force. Let's take that force as R. Let's take that force as R. Okay. This R force stops this guy, right? This R force stops this guy. Clear? So that R force is the force felt by the spring that would be shown in the electronic balance, right? Whatever the force felt by the spring will be shown in the electronic balance as weight, right? Clear? So you apply for this guy, you apply F equals ma. Pay attention. In upward direction, you have the force R. In downward direction, you have the weight 50. You have the weight of the object 50. R minus 50. What is the mass? 5 kilograms. Mass 5 kilograms. And what is the acceleration? What is the acceleration? Acceleration is final velocity minus initial velocity over time, right? Final velocity minus initial velocity over time. So what is the final velocity? 0. Minus, what is the initial velocity? 20, but minus 20. Why minus 20? I have chosen a direction for my equation which is upward direction. If you choose a direction for a vector equation, whatever the quantities that are in opposite direction should be minus, right? Clear? So, in upward direction, initial velocity is minus 20. Why? The velocity is downward. Clear? Over time, it takes 0.01 seconds for this velocity change. So you are going to get R minus 50 equals 5. Here minus minus means plus. Plus 20 over 0.01. You multiply up and down by 100. Here 5 into 2, 20 is 100 over 0.01. You multiply up and down by 100, then you get this over 1. You multiply both up and down by 100. This is equal to R minus 50. Then R equals, I take this 50 there, 10,000 plus 50, which means 10, 0, and 50 newtons. Then, what is the reading of the electronic balance? What is the reading of the electronic balance? Overall reading would be initially, pay attention, initially there's 400 newtons. Overall reading, that means mg would be, initially there's 400 newtons. Now due to the collision, it creates 10050 newtons. So the overall reading would be 10450 newtons. Clear? Clear? Got the idea? This would be the overall reading. I just needed to teach you this scenario. This is not an actual question because I have seen these kind of stuff happening in a lot of term test papers and all. Okay. What happened was a bunch of marbles are filled in this. Okay. Which creates an overall force of 400 newtons. And one guy come and collide and stops within 0.01 seconds. Due to that collision, it creates a huge impact on the spring balance. Clear? This collision creates a huge impact on the spring balance. So we have to add that component too. Okay? So this guy reaches with a velocity of 20 and becomes 0. This guy reaches with a velocity of 20 and becomes 0. Okay? So I can apply F equals ma. This spring is providing an upward force on this ball. That's why it stops. That force is felt by the spring. That force felt by the spring in the electronic balance is shown as the reading, right? So R minus 50. Why minus 50? There's a weight downwards equals mass is 5 kilogram. What is the change in velocity over time? 0 minus 20 over time is 0.01 seconds. Velocity difference over time. So when you solve this, you get R equals this. That means you have 400 newtons already stationary balls, and there's one guy come and collide, which creates a huge force. So the overall force felt by the balance is this one. Clear? Overall force felt by the balance is this one. Okay? So let's do it this way. You can take the interval. I'll start around 6:20. Pay attention. Others can come and try to finish this exercise. Try to finish the exercise, especially 10, especially exercise 2, question 10, exercise 2, question 10. And pay attention. I would explain this question again exactly at 6:30. So students who need this explanation again, be here on time, and others be here on time and start doing this question. I would explain this question again. And whatever the questions you have, ask. Okay? Whatever the questions you have, ask in the interval. Then based on that, I would explain this question again just after the interval. Others, take the interval and try exercise 2, question 10. Okay. Be silent, everyone. I'll explain this again. Stop talking. Stop talking, everyone. Front row, stop talking. Okay. Pay attention. I mean, just keep doing the questions. If you are okay with this, keep doing the questions. Others listen, but everyone stop talking because like some students are listening. Okay. Others finish exercise 2, question 10 and the revision tute. So again, be silent. Again, the question is, we drop a 5 kilogram ball every second to this electronic balance from a height of 20 meters. What is the reading shown at the scale at 10th second? Although I asked for the 10th second, be silent. Although I asked for the 10th second, I'm asking about an average around 10 second. Be silent. I'm asking about an average around 10 second. So in this case, what happens is, we release a ball at 0th second, first, second, third, fourth, 5, 6, 7, 8, like that. We keep releasing a ball every second. Then I apply S equals ut plus half at squared from here to here. I apply S equals ut plus half at squared from here to here. Distance is 20. Starting velocity 0 plus half. Acceleration 10 t squared. Then time to this point is 2 seconds. Time to this point is 2 seconds. Be silent. Time to this point is 2 seconds. That means every ball released take 2 seconds to reach here. That means the ball I released at 0th second would reach here at second. The ball I release at first second reach here at third second. Every ball would take 2 seconds to reach here. Clear? Every ball will take 2 seconds to reach here. Okay, stop talking. So, what I'm interested in is 10th second. Okay, but since it takes 2 seconds for every ball to reach, okay, only the ball that I released at 8th second reach here at 10th second, right? Other 2 balls are on the way. Okay, pay attention. So I release a ball at 0th second, first, second, third, fourth, fifth, sixth, 7th. And the ball I release at 7th second reach the balance by 9th second, right? It takes 2 seconds to reach. Clear? It takes 2 seconds to go from here to here. So the ball I released at 7th second reach here by 9th second. Now, all these balls 0, 1, 2, 3, 4, 5, 6, 7 are stationary by now. All other balls are stationary by now. Okay? That means 0 to 7 means 0, 1, 2, 3, 4, 5, 6, 7. That means 8 balls, right? 1, 2, 3, 4, 5, 6, 7, 8. Altogether 8 balls. Stop talking. Altogether 8 balls have reached here. What is the weight of 8 balls? 8 into 50. One is 5 kilograms. That means 50 newtons. So 8 into 50 is 400 newtons. So already this electronic balance feel a weight of 400 newtons. Clear? It already feel a weight of 400 newtons. Okay? Now, what about this guy? What about this guy? It reached the balance just at 10 second, right? The ball you release at 8 second, it takes 2 seconds to reach here. So it reach here at 10th second. Clear? It reach here at 10 second. So at 10th second, okay, last rows, can you hear me? At 10th second, it's not only this weight, a collision happens. A collision happens. Due to that collision, the reading goes up. Due to that collision, reading goes up. Okay. So when you apply, stop talking. When you apply v squared equals u squared plus 2as from here to here, when you apply v squared equals u squared plus 2as from here to here, velocity here is 20. Starting velocity 0, 2, 10, 20. Velocity here becomes 20. So now I mentioned that this ball reached the balance with a velocity of 20 and becomes stationary within 0.01 seconds. Okay. Due to what force does it become stationary? Stop talking. Due to what force does it become stationary? What is the reason? Due to the force provided by the spring in the electronic balance, right? Spring in the electronic balance provide a force, upward force. So that is R. So I apply F equals ma. It feels an upward force of R and its weight is 50. Its weight is 50. So it is R minus 50 equals m, mass is 5. And what is the acceleration? Velocity goes from 20 to 0 within 0.01 seconds. That is the acceleration. Velocity changes from 20 to 0 in 0.01 seconds. So velocity difference over time. When you solve this, you get R minus 50 equals 10,000. When you solve this, you get R minus 50. When you solve this part, you get 10,000. So R equals, you take this 50 to this side. You take this 50 to this side. So R equals 10,000 plus 50. Stop talking. R equals 10,000 plus additional 50. Clear? Clear? You take this 50 to this side. Then R is 10050 newtons. Now, you have the weight of previous balls and force by the collision, both added together and shown in the electronic balance. So the overall weight shown in the balance is weight of this one, which means 400 newtons. Weight of this one is 400 newtons plus this additional force. Clear? This is what you would read at 10th second. Okay? But actually, why do I read this as mg? Why do I read this as mg? Because that is, mg is weight. That is the weight shown in the electronic balance. Okay? So, if you, when you are measuring something, okay, when you are measuring something, if you release it onto the balance, okay, you would see a different reading. If you release 5 kilograms from a height, you would read something like not 50 newtons, something like 70 newtons. Why? It's the weight plus the collision. Collision. Clear? Okay. Now, is that clear? The students who asked the question, who asked me to explain this again, is that clear? Just let me know in the Zoom chat. This is also a data in question, 0.01 seconds. It takes 0.01 seconds for this ball to slow down, okay, after the collision. Is that clear? Just let me know, at least send a sheet mentioning whether it's clear or not, or whether you need me to explain this again. And there was a student who asked me to explain this again. Is that clear? And mg means just the weight shown in the balance. mg means the weight shown in the balance. That's all. Is that clear? Okay. Pay attention, everyone. Take your book or the note. Write Newton's third law. Newton's third law. Write Newton's third law. Write the topic Newton's third law. Be silent, everyone. Stop talking. Be silent. Middle rows, be silent. Okay. Every action has a reaction which is opposite in direction. Every action has a reaction which is equal in magnitude and opposite in direction. Every action has a reaction. Newton's third law. Every action has a reaction which is equal in magnitude and opposite in direction. Every action has a reaction which is equal in magnitude and opposite in direction. Every action has a reaction which is equal in magnitude and opposite in direction. Just let me know, or else at least send a sheet mentioning that if you need me to explain this again. But I won't be explaining this again in the class. At least I can provide a recording if there's a lot of students who didn't understand this, okay? The reason for me to take this complex example, I have seen these kind of questions. So you should know how to handle a scenario like this, okay? So, like talking about action-reaction pairs, there's a series of rules, okay? There's a series of rules. Okay, pay attention. Pay attention, everyone. Okay. So if you apply a force on the wall like this, okay? If you apply a force on the wall like this, it will feel a reaction like this. It will feel a reaction like this. There are some properties of these action-reaction pairs, okay? There are some important properties in these action-reaction pairs. They are, one is, these two forces are equal in magnitude. If you apply 5 newtons on a wall, you would feel 5 newtons on your hand, okay? And they are opposite in direction. And one more important fact is, it always acts on two objects. That means if the action is on the wall, reaction is on the hand, okay? If the action is on the wall, reaction is on the hand, okay? And there's one misconception, okay? There's one misconception that students always make. The weight of this person is mg. Weight of this person is mg. Now, the flow provides an reaction on this person, right? The flow provides a reaction on this person, right? What is the usual value of this reaction? Usual value of this reaction is again equal to mg. Why? Usual reaction is equal to mg. Why? Because these two forces should be equal to stop this person from going down, right? There's a mg downward force acting on the person, r upward force acting on this person. If these two forces are not balanced, the person would go down, right? So definitely r should be equal to mg. So there's a very high chance that they may ask this in the first term test. So, because it is a very common misconception, can we consider these two as an action-reaction pair? Can we consider R and Mg as an action-reaction pair? We can't consider R and Mg as an action-reaction pair. Why? What is the reason? The reason is like this. If this is the earth, okay? If this is the earth, you will understand this very properly when we finish gravitation lesson. There's something called Newton's gravitational law, which you don't know at the moment. But this mg weight is felt due to the gravitational pull by earth. That means this mg weight is felt due to the pull, gravitational pull by earth. That means one mass can attract another mass. That's how it happens, okay? So sun creates an attractive force on earth. That's why we are going around that without going away, okay? Like that, a mass can create a force on another mass, okay? Okay. So if mg is the weight, that weight is there due to the gravitational pull. Okay. Who's the reason behind the gravitational pull? It's earth. So you can see the same gravitational pull is there on earth in opposite direction at the center of the earth. That means every action has a reaction. Earth pulls us with a force of mg. So we pull earth with the same force. Okay. That's how gravity works. Okay. That's how gravity works. That means if you have two planets like this planet exerts a force on this planet, value is F, and this planet exerts the same force on this planet and the magnitude is F. That's how gravity works. There's an attractive force always between mass. Clear? Clear? That's how gravitational forces work. And these two, they are an action-reaction pair, okay? This is an action-reaction pair. Why? Equal in magnitude, opposite in direction, but acting on two objects. And these two objects should be the objects who created this force. That means if my hand is creating a force on this board, the reaction should be on my hand, not on my leg, okay? Okay? If there's a object who's the reason for this force, the reaction should be on that thing. So if the earth pulls us downward, reaction should be on the center of earth. Okay? Okay? Clear? So lucky. So that's why if we jump up, that's why we fall down. due to this pull. Okay, clear? Okay. Now, so the reaction of your weight mg, reaction of your weight mg is this one. Okay, reaction of your weight is this one mg. Clear? Now, due to your weight, okay, pay attention. Due to your weight, you try to go down on the surface of earth. Okay, you try to go down. Due to that reason, you create a compression on earth. Due to that reason, you create a compression on earth. That's why when you walk, not on a tile, like you create a footmark. Why? Because you create a compression on earth. Okay, and that compression is R. That compression is R. And the surface of earth creates a reaction for that, which is R. That's what you feel. That's what you feel. Okay. So when you consider the equilibrium of the person, R equals mg. It's true. R equals mg. But R and mg are not action-reaction pairs. Okay. This mg gravitational pull is not due to the surface of Earth. It's due to the whole mass of Earth. So the reason behind this mg force is my mass and the mass of Earth. So the action reaction pair should be on my center and center of Earth. So these two are an action reaction pair. But due to this force, I compress Earth. I create an R compression on Earth. And the reaction of that compression is this R. That's how it works, okay? Properly understand these action reaction pairs because you may need them when analyzing questions, okay? Clear? And there's a lot of scenarios that we see student makes mistakes, and if it is a 1 MCQ, it matters, okay? Definitely in A levels, 1 MCQ matters. I always explain this because 1 MCQ means around 30-40 of your district rank and around 100-150 of your island rank, okay? This is a competitive exam, okay? So every small detail matters. Try to understand these things properly. Is that clear? Is that clear? Okay. That's how it works. Okay. Okay. And yeah, there was a lot of kids asking for something for the Children's Day. I mean, that's why I asked when you have holidays. I mean, food you can buy, right? You can't buy physics, like it's not that cheap. So, yeah. So that's why I asked you for some holidays to do some extra classes. Okay. Uh, Pay attention. And regarding the paper discussion today, I mean, I'm just mentioning this because if there's someone deciding to whether to stay or leaving, I'm not going to discuss 15th question today. Okay, I'm not going to discuss 15th question today. I will provide a recording within today or tomorrow for the 15th question because it would take at least half an hour to discuss the 15th question. So I mean, it's useless if I try to explain this now. I mean, it can be done within 10 minutes, okay? Just it takes half an hour to explain that. That's why. So 15th one, I would provide a recording. Other questions I'll explain today, okay? I just mentioned if there's someone like planning to stay for the discussion only for the 15th question. Today I'm not going to discuss the 15th one. I would do it uh, like today as a recording or tomorrow as a recording. Okay. Okay. Exercise 2 question 10. I asked you to try this. I'll try the first one and give other questions as homework. Thank you. Thank you. Okay. Okay, we have a lot of papers today. Marks, Gavinu. Gavinu. 15. 15. Ovindi. Akisha. 14. Situka Tarun. Again, 14. Sharon Rodrigo. 13. Ritika Metnula. 13. Sayumdi Vandara. 13. Sayumli Aberatna. Sayumli. 13. Ah- Ahasna. 12. Eron. Eron. 12. Shazan. Shazan Shafi. 12. Dinara Tuljan. 12. Okay, I can read this. Can you read this? Tinu? Tinuka. Tinuka. 12. Akita Dinhas. 12. And online marks. Vidush Induvara 15. Shinali Moraes 14. Chamatka Javir 14. Senuki Abegunavardhana 14. Chenita Mathota 14. Tanuji Hansika 13. Vimukti Madhugal 13. Jayani 13. Naditi Nithaya 13. MC Patirana 13. Lasal Nayakar 12. Bhutmi Tinara 12. Lituka Dayananda 12. So marks are like relatively okay actually. But always try, okay? Pay attention. Pay attention. Always try to push your marks up, okay? Always try to push your marks up, but paper changes every week. Some weeks the paper is really easy, some weeks the paper is really difficult, the paper changes, okay? Pay attention, everyone. Stop talking. Stop talking. Stop talking. What matters is whether you can handle every paper. That means whatever the paper you get, try to keep an average mark. That means assume like there are like 5 really difficult questions in the paper, maybe 8. What I need you to do is forget those 8 questions and I need 12 marks. Okay. What usually happens in sometimes in papers is when we give 5 really difficult papers, marks go down to sometimes 6, 7 or 5. There's only 5 really difficult questions, but the impact continues for 5 more additional questions. That should never happen. So keep that clarity in your mind when you are doing a question. First analyze, is this question easy or not? If it is really difficult, if it is not in your scope, leave that. You can leave 8 questions and still get, like, you can leave 8 questions and still get around 5, 6 marks, right? You can leave 4 questions entirely and try to go get 11 marks, right? So keep that clarity in your mind when you are doing papers, okay? Difficult questions are difficult, forget them. And there's a bunch of easy questions. What matters first is those easy questions. You should finish those easy questions first, then focus on only if you have additional time, you should focus on other questions, okay? That clarity you should have in your mind, okay? Okay. Exercise 2, question 10, part 1, sorry, A. This is 30 newtons. This is 30 newtons. There's a force of 30 newtons here. Mass is 4 kilograms. Mass is 4 kilograms. 4 kilograms means 40 newtons. 40 newtons. Pay attention, everyone. Stop talking. Stop talking. Okay. Weight is 40 newtons. Okay. Focus. Brown t-shirt. Okay. So, weight is 40 newtons. Weight is 40 newtons. So, if this is 30, then this is 90. If this is 90, then this is 60. We have done this previously. If that is 60, this angle will be 30. Can you remember? Can you remember? If this is 60, this is 90, then this is 90, then this is 60. Why? 60 plus 30 should be 90. Then this is 90 angle. So if this is 60, this should be 30. So again, I can resolve this vector into 2 directions. I can resolve this vector into 2 directions like this. This would be 40 cos 30. This would be 40 cos 30. 40. When you go through the angle, it is cos 30. And this should be 40 sin 30. This should be 40 sin 30. So 40 sin 30 means 40 into sin 30 means half, which means 20. Which means 20. Now, as you see, this component is entirely useless because you can't go into the plane, right? This component is entirely useless because you can't go into the plane, right? You can't rush into the plane. So what matters is this force and this force. Okay? What matters is this force and this one. Okay? That means you have this 30 newtons in this direction and this 20 newtons in opposite direction. Then you can apply F equals MA, F equals MA in this direction. So the force here is 30 newtons minus the opposite force is 20. Opposite force is 20. 30 minus 20 equals, what is the mass? Mass is 4 kilograms. Mass is 4 kilograms. So the mass 4 kilograms and acceleration is A. Acceleration is A. So 30 minus 20 is 10 equals 4A. A equals 10 over 4, which means 2.5 meters per second squared. 2.5 meters per second squared. Is that clear? Is that clear? Okay. Pay attention. Okay. Now, what I would do is, you can try other questions in exercise 2 as homework and ask questions next week. I would discuss questions of exercise 2 next week. Okay. So try the whole exercise 2, all the questions remaining in exercise 2, and I would discuss them next week. I'll move to a small theory part. Pay attention. Class is not over. Next, pay attention. Otherwise, you don't have enough work to do. That's why. Okay. Because there's only a few questions left in exercise 2. So you don't have enough stuff to do at home. That's why I'm doing another small theory part, which is, pay attention. Stop talking, everyone. Anyone need more clarification about this? Anyone? Anyone? What is the problem? Is this no issue? Anyone? Questions? No, right? Okay. So now what we have to do is, since we have finished Newton's laws, now there are different types of law, different types of forces. Tension, compression, friction. Okay. There are different types of forces. Now we have to analyze one by one. Okay. We have to analyze one by one. In that path, the first force that we are going to learn is the tension. Tension. What is the tension? Tension is, if you take a string or any object, it has its own natural length. Any object, pay attention, any object have its own natural length. What is the meaning of this natural length? Meaning of this natural length is, its particles in the sense its atoms would like to stay in a neutral state when it is at rest. It's made out of atoms, and when it is at rest, its atoms are at an ideal distance. They are at an ideal distance. Okay. Now you provide a force and try to stretch this wire or the string. As a result, its particles, the distance between its particles increase from its ideal length. So ideally, they like to stay in an ideal distance like this. Ideally, its atoms like to stay in an ideal distance like this. But when you provide a force and try to increase the length, its particles distance passes its ideal length and the distance increases. These particles don't like this. Okay? So there are intermolecular forces and all acts, and it try to return the system. A force acts between these atoms. When they pass the ideal distance, a force acts between these atoms. Clear? Clear? So they can neutrally stay at a distance like this, okay? They can neutrally stay at a distance like this. But when you apply a force and increase the distance, a force appears between these atoms. A force appears between these atoms. This force tries to return it to the initial length. So if you release the force, due to these forces, it would return to the initial state, okay? If you give up this force, if you remove this force, it would again return to the initial state due to these forces acting between its atoms. This force acting between its atoms, we call that the tension. Clear? We call that the tension. So what happens is, if you apply a force like this, okay, to balance that, another force F will appear here between these two atoms. If you apply a force F in this side, okay, another force F may appear between these two atoms trying to stop this force. And the reaction of this force is this one. Clear? Then to stop this particle from going away, this particle will create a force F on this atom. And the reaction of that force is this one. Now to stop this atom from going away due to that force, okay, this atom will create a force F. Okay? And its reaction is this. So as a result, if you apply a force F on a string, that force continues throughout the string. You can see the same force everywhere in the string. Same tension. Clear? Clear? Why? Because it is an internal force. It is an internal force. See, if this is the string, see, both action and reaction is inside the rope. Both action and reaction is inside the rope. Both action and reaction is inside the rope. Clear? It is an internal force that occurs in a string or something that is stretched as a result of its particles going away from their natural position, natural length. That means tension is something that tries to bring the system into the initial length again. Now all of a sudden, if you remove this force, if you take your hand, what happens? Due to this force, this particle would move in this direction. This particle will move in this direction. This will move in this direction. And they will return to their initial state. Okay? And how do we mark the tension? How do we mark the tension? It's like this. Assume you have a system like this. Maybe a system like this. And you apply a force F here. Now, if this block is not moving away, there's a tension T1 acting on this block. Clear? And that this is that tension, see? This end of the rope. And that tension continues until here, the other end of the rope, and it's acting in this direction. So as a result, this block will feel the same tension in the opposite direction. See? See? This is this F. And this is the other end of the rope. It's acting in the opposite direction. Now, due to this force, another tension may occur in this string. It will be another tension, maybe T2. Maybe T2. This is T2. Clear? And it continues until here, and it will be acting on the wall. Clear? And if you remove the wall, the system will accelerate. Clear? If you remove the wall, the system will accelerate. Again, if you have something like this, if this is 5 kilograms, that means its weight is 50. Its weight is 50. Now a tension may occur due to this force. It is this one. And it continues throughout the string and go to the other end of the string and acts in opposite direction. So this wall will feel the same tension. This wall will feel the same tension. Now if you consider the equilibrium of this guy, since it is not moving, T should be 50 newtons. T should be 50 newtons, right? Why? This is not moving. That means its forces are balanced. So it has downward 50 newtons, upward tension T. Upward tension T. So T equals 50 newtons. Clear? T equals 50 newtons. Same 50 newtons will be felt by this wall. Clear? Same 50 newtons will be felt by this wall. Why? Due to, since this tension continues till this wall. Clear? That's how we mark the tension. Okay? That's how we mark the tension. Okay? Again, if you take a pulley, something like this, and you hang something here and here, then what happens? Assume that this is 5 kilograms and this is 3 kilograms. Then this is 50 newtons. 5 kilograms means 50 newtons. This is 30 newtons. Clear? Now, a tension may appear here. Tension may appear here. And that tension will continue until this point through the string, and it will appear here in the opposite direction. Because it's the same string going through the pulley, right? So same force continues until the other end and acts in the opposite direction. Okay? So the tension acting on this object would be T, and the tension acting on this object would be again T. And if you consider the pulley, okay, it would again feel the tension in both sides, right? So why? There's a tension acting like this on the pulley, and there's a tension like this acting on the pulley, right? Clear? Clear? So the pulley would feel 2 into the tension. Clear? And this rope, who's balancing the pulley, would have to create another tension to balance this pulley. Okay? That's how it continues. Okay? And if I go further, if it is balanced like this string should stretch and create a tension on this, and it will continue until this end, T2. It will continue until this end. That's how the tension works. Clear? That means if you take a string like this, okay, that tension is everywhere. Why? It's an internal force. Clear? It goes like this between particles everywhere in the string. Clear? Because it is an internal force acting between particles. So between every atom, this force acts. Okay? Between every molecule, this force acts. Clear? That's how we mark the tension. So next week, we can start with exercise 3 questions. Can someone remind me that we have to start with exercise 3 questions next week? Sure? Sure? Okay. remind me that we have to start with exercise 3 questions. Pay attention. Finish exercise 2 for sure. Exercise 3, just read and try few questions, but you would find it hard because we haven't done enough questions yet. So if you are not going to do exercise 3, it's okay. Just read some questions, go through the theory and come to the class. But definitely finish exercise 2. Okay. I would start with exercise 3 and exercise 2 next week. Okay. Okay, everyone, remind me that I have to start with exercise 3 next week. Okay. And I'll inform about the other term test papers. If not tomorrow, I would be doing the next term test discussion on next Tuesday. Okay. I would try to do at least 2, 3 term test paper discussions every week now on. Okay. So I'll start around, let's start the paper discussion around 7:30. Okay. You don't need 2 intervals. Okay. So be here. Okay. Be here. I'll start the paper discussion around 7:30. Yeah. Sure. And new students, give your number to like our coordinators. They will add you to the group and ask for any recordings if you need. Okay, let's start the paper. Let's start the paper discussion. So first steps first, write down the question numbers that you need me to discuss. Okay. Everyone write down the question numbers that you need me to discuss of today's model paper. Discuss the questions, numbers that you need me to discuss. Like just write it on a paper. Write the question numbers that you need me to discuss. Okay. And online students also mention it in the Zoom chat. Okay. So a lot of students have asked question 10. Today we are going to discuss model paper 40. Model paper 40. Uh, let's start with question 10. Let's start with question 10. An object is released from rest from a height h. Released from rest. Object is released from rest from a height h. When it hits the ground, its speed is 80% of the speed it would have had if it fell freely. Find the approximate maximum height the object reaches after the impact. Find the approximate maximum height the object would reach after the impact. When it hits the ground, its speed is 80% of the speed it would have had if it fell freely. So I think there's a small confusion in the question. That's why a lot of students have asked. Okay. There's a small confusion in this question. I think what they have asked is, if you lose 20% of the energy after the collision, what is the maximum height that you would reach, right? Pay attention. Stop talking, everyone. Okay. So, starting velocity, 0, and you fall for a height of h. Then the velocity here would be v1. Velocity here would be v1. I can use downward v squared equals u squared plus 2as. So the final velocity is v1, v1 squared, starting velocity 0 plus 2, 2. Acceleration downward, gravitational acceleration. Downward acceleration is gravitational acceleration, 2g. Height is h, 2gh, 2g and h. So you are going to get v1 equals square root 2gh. v1 equals square root 2gh. Now after the collision, it returns with a velocity of v2. And v2 is 80% of v1. v2 is 80% of v1. Clear? Here v2 is 80% of v1. Only provide the paper in the Zoom chat. And if anyone needs to get the paper, contact this number, 070-154-6825. If you are joining through another platform, and if you need the paper now, just contact this number, okay? And others can get the paper from the Zoom chat, or again, it's available in the WhatsApp group too. So 80% of V1, which means 0.8 V1. Then the maximum height it would obtain now would be, now it goes up and reach a maximum height when the velocity is 0. It reach a maximum height when the velocity is 0. Let's take that height as h2. Let's take that height as h2. So I can apply in upward direction, I can apply v squared equals u squared plus 2as. Final velocity is 0. Starting velocity v2 squared plus 2. Gravity is downward, so minus g. Gravity is downward, so minus g. Height h2. Height h2. So you get 0 equals v2 squared minus 2g h2. v2 squared minus 2gh2, and I'm going to take 2gh2 to this side. 2gh2 equals v2 squared. v2 squared means 0.8 squared. 0.8 squared v1 squared. v2 squared means 0.8 squared v1 squared, which means 0.8 squared. What is v1 squared? v1 squared is 2gh. v1 squared is 2gh. Here you have 2gh2. Here you have 2gh2. 2 and g cancels out. h2 is 0.8 squared h. 0.8 squared h. What is 0.8 squared? 0.64 h. 0.64 h. Then let's go to question 13. Let's go to question 13. I mean, I'm not going to give you enough time to write this down. You can always watch the recording and write this down, or else you can watch the review and go through the review and write this. Okay, only put the review in the WhatsApp group and check if we haven't provided any reviews, and provide all the reviews in the WhatsApp group and add to the website too. Okay, so the reviews will be available in the website and the WhatsApp group. So I'm not going to give enough time to time to write, okay? If you have some additional points to write down, some important facts, write them down. If your writing is really fast, you can write the whole answer. Otherwise, don't try to write, because I mean, I can't give enough time to write. I'm with the target of finishing the full paper, if possible. So let's move to question 13. Let's move to question 13. Question 13. A trolley of length AB, a trolley of length AB and mass M has a small mass simple M placed at a position A, as shown in the figure. The trolley is moving with a constant velocity root 3v. When the small mass is released with a velocity v relative to the trolley, among the following statements, the correct one is. Okay. So, mass is m, and you throw with a velocity v, and you throw with a velocity v, and the angle is 30. Angle is 30. And this velocity is root 3v. This velocity is root 3v. In this question, they mentioned that we throw this guy relative to the trolley, right? We throw this relative to the trolley. That means I can entirely forget the motion of trolley, right? I can entirely forget the motion of trolley. Okay? That means, okay? That means, if you have a bus, okay, if you are in a bus, if you need to throw something from here to a person at this point, do you have to do a calculation and include the velocity of bus there? No. If the bus is moving with a constant velocity, you just throw. Why? What matters is the velocity is relative to the bus. How fast do you throw it? What matters is how fast you throw it relative to the bus. Clear? How fast you throw it relative to the bus. Okay? That means, okay, that means I can entirely forget about this velocity, right? Why? Because if I throw this relative to the trolley, this root 3v includes here and here both, right? If both have the same velocity, that equal velocity components I can forget, right? Clear? So I can entirely forget this root 3v because everything is given relative to the trolley. Clear? So I would apply all my equations relative to the trolley, then I can forget the motion of trolley, okay? I would apply all the equations relative to the trolley, then I can forget the motion of trolley, right? If all the equations are applied relative to the trolley. For an example, we do a lot of questions relative to Earth. I mean, if you were going to include the velocity of Earth there, Earth is moving some like 30 kilometers per second. Velocity, Earth is moving at a velocity of 30 kilometers per second, I think. Earth is moving at a huge velocity. But why do we forget that always? Because we are applying all the questions, we are applying all the equations relative to Earth. Like that, if you are applying equations relative to the trolley, you can forget the motion of trolley. So it's just a throw. So it's just a throw that happens with an angle of 30 with a velocity of v. And what would be the range? What would be the range of this projectile? Range of this projectile would be, as I remember, I asked you to remember these equations for the first term test. Okay, 2 v squared sine theta cos theta. What do we have here? G, right? That's all right. 2 v squared sine theta cos theta over g, right? Can you remember I asked you to remember the equations for range, maximum height, things like that, time of flight. So this is 2. What is the velocity v? Sine 30 cos 30 sine 30 cos 30 over g. Over g, g means 10. G means 10. So I'm going to get 2v squared sine 30 is half, cos 30 is root 3 over 2. Again here 1 over 10. So this 2 and this 2 will cancel out. Then I'm left with what? I'm left with root 3 v squared over 20. I'm left with root 3 v squared over 20. Then the length of the trolley is L. Length of the trolley is L. So this will fall back into the trolley if what happens? The mass m again reaches to the same horizontal level between A and B. So it returns to the trolley, right? That means it returns to the trolley if the length of the trolley is larger than R, right? If L is larger than R is the range of this projectile. If the length of the trolley is larger than the range, clear? If the length of the trolley is larger than the range, then it would again fall back to the trolley, right? So what should happen is L should be larger than R. R is root 3 v squared over 20. Root 3 v squared over 20. Clear? That's what you have to consider. Pay attention. For the 13th question, pay attention. For the 13th question, why can't we get the fourth answer? Fourth answer is L equals root 3 v squared over 20. Why can't I get this answer? Even in A levels, we expect the best answer. That means even in A levels, what they mention is choose the best possible answer. So they are asking for the condition for this to fall back, to make sure that this falls again to the trolley. Okay. So this is just the edge case, which it would just hit the edge. But this is the better scenario. That means if this is confirmed, then it would definitely fall into this. Okay. So I mean, meaning of this is only this is correct. Only this is correct. I mean, pay attention. This is how we think. Okay. This is how we think. When you have both answers, okay. When you have both answers, if you choose this, the meaning is only this is correct. If L is larger than this, then it can't happen. But that's not the case, right? If L is larger than this, still it falls to the trolley. So when you have both the answers, if you choose this as the answer, the meaning of that is you are telling that this is the only possible answer. If L is larger than this, it can't happen. But it actually happens when L is larger than this, right? That's how we reason, okay? That's how we reason in a paper. And again, so it's quite simple like that, okay? Again, question 7, some students have asked. Pay attention, pay attention, stop talking. Question 7, some students have asked. The reason is you have two answers. 5 meters per second squared and 5 meters per second, okay? This is the answer, okay? This is the answer. Don't just look into the value. Look into the unit 2, okay? Focus on the unit 2. In A levels, you may find a lot of instances like this. You get the answer as 5. Usually in A levels, first answer is 5 meters per second squared. Usually in A levels, first answer is 5 meters per second squared. Then in the third or fourth answer, you have the correct one. Okay? Because when students are in a hurry, they usually choose this answer. Okay? And accuracy matters a lot in A levels. Okay? Actually, in A levels, for a student who works properly, what matters is accuracy. Because when you do a lot of questions, you are capable of handling any question in A levels. What you would miss is this kind of stuff, okay? So focus on this, okay? There will be a lot of scenarios like this in future papers, okay? There will be a lot of scenarios like this in future papers. You have to learn to avoid these scenarios. Why? Definitely A level, I mean, it's definitely A levels we choose for medicine too. So we need accurate people at the end of the day, okay? So there's a lot of scenarios that you can make careless mistakes in a A-level paper. In A-level paper, it's not, the physics is not really difficult. What is difficult is like avoiding these kind of scenarios. There's a lot of scenarios like this, okay, that you should avoid somehow. Okay, that's why I think, otherwise there's nothing to discuss here, okay? There's nothing to discuss here. It should be 5 meters per second, okay? In the future, there will be a lot of scenarios like that. You should be careful and handle them properly. Otherwise, you would lose a lot of marks. Okay. Next. Actually, I have the whole paper here. I'm just going through the everything and choose the questions asked by a lot of students. Let's go to question 12 and 14. 12 and 14. Question 12. As shown in the figure, two trolleys A and B move with a constant velocity v along two parallel straight horizontal tracks. Observers X and Y are on trolleys and Z is observer on the ground. If X releases an object P from their hand, neglecting air resistance, the path of P as observed by X, Y, and Z. X, Y, and Z. X, Y, and Z, and the ball. Pay attention. Now, X has a velocity V in this direction. Y has a velocity V in this direction. and Z has zero velocity. Okay. And for the ball, since you release it, from X, pay attention, stop talking. Since you release it from X, it would have the velocity of X, right? It would have the velocity of X. And due to gravity, it would fall down. It would fall down. Clear? Now, what we usually see is relative velocity. That means if my velocity is v, and if there's a vehicle moving with a velocity of v, if our velocities are equal, I won't see that vehicle moving, right? If my velocity and another vehicle going parallel to me, if we have the same velocity, from my point of view, that is stationary, right? That is not moving. Clear? So, since this velocity component is common to x and y and the ball, x and y won't see this velocity component. So it would see only this component. That means from the view of x, this would fall down. From the view of y, this would just fall down. Why? This component is common to all three. Common components we can never see. That's why I can't see you moving with a velocity of 30 kilometers per second. Why? Because I'm also moving with the same velocity because I'm on Earth and you're on Earth. We both are moving with a velocity of 30 kilometers per second. Since we have that velocity in common, I can't see that velocity in you. Clear? And you can't see that velocity in me. Okay? So the common components we can't see. So these two guys see only this component. But for this guy, since it is stationary, he can see both components. Clear? So when you have the both components, your path would be like this. Clear? So answer should be the first one, right? Answer should be the first one. So in the future papers, in some papers, it would 30% of your marks would depend based on your careless mistakes, okay? Because that is one of the most crucial facts in A levels, okay? We can be really good in physics, but we make few careless mistakes, then the result is gone, okay? So we have to focus a lot on careless mistakes. We have to be really accurate. Question 14. Question 14. Question 14. Just let me know if you have any other requests. And any questions up to this point? Any questions up to this point? Yeah. Lot of students ask the third question too. So after 14, I'll discuss third one. After fourth, I'll discuss third one. Question 14. Point A and B lie on the same horizontal plane. Point A and B lie on the same horizontal plane. And the starting velocity is u. Here the velocity is root 2u. But we don't know this theta. This is pi over 4. And it goes like this. And this goes like this. And they collide at a certain point. And this horizontal distance is u squared over g. Horizontal distance is u squared over g. Okay. Horizontal distance is u squared over g. Then in the question, like for two objects, pay attention, stop talking. For two objects to collide, what should happen? For two objects to collide, their vertical displacement should be equal and horizontal displacement should be equal at the same time, right? That means at t equals t, their vertical displacement should be equal and horizontal displacement, sum of two horizontal displacement should be u squared over g, right? For them to collide. So if the vertical height is h, pay attention, if the vertical height is h, okay, if the vertical height is h, I can apply, because now I have to find two variables in this question, so definitely I need more than one or two equations. Why? I don't know theta, I don't know the time, right? So there are two variables anyways, okay? There are two variables anyways that I have to find. Clear? So the easiest way is first, vertical displacement of both objects should be equal, right? Otherwise they would never collide, right? Their vertical displacements should be equal. Clear? So S equals ut plus half at squared in upward direction. Pay attention. Pay attention. In upward direction, height is h. Height is h. Height is h. And I can write for this guy, starting vertical velocity u sine 45. Starting vertical velocity u sine 45. Time is capital T plus half. Stop talking. Plus half. What is the acceleration? Acceleration is minus g, right? Again t squared. Again t squared. Okay. Then for the other object, so this is h equals u over root 2. This is u sine 45, that means u over root 2. U over root 2 minus g over 2 t squared. Here also you have a t. Now for the other object, s equals ut plus half at squared in upward direction. So height is again h. Starting velocity root 2u sine theta. Root 2u sine theta t plus half minus g t squared minus gt squared. Then I have h equals root 2 u sine theta. Here I can write minus g over 2 t squared I mean, I actually don't have to go through. I mean, I actually pay attention. Stop talking, everyone. Uh, I actually don't have to go through the. Here you have T. Here you have T. I mean, please do understand, okay? Sometimes when I'm doing questions, you may feel like the question is really long. These are not actually long, okay? It takes time to explain, but the question is not lengthy, okay? Because, I mean, now I'm doing all this stuff to prove one thing. What is that? I'm doing this everything to prove one thing. What is that? See, take this one. I can write, I would take this one here. So h plus g over 2 t squared. I'll take this guy here. Okay. Then divide it by t. Divide it by t. Equals what? U over root 2. U over root 2. Clear? I keep h here, bring half gt squared here and divide by t. Clear? Then here also I would get, see, h plus I would take this guy here, half gt squared, again divide by t, then I'm left with root 2u sine theta. Root 2u sine theta. What I'm trying to prove is, this is the vertical velocity component of this guy. This is the vertical velocity component of the other guy. These two are equal. Why? See, this one and this one is equal. See, h plus half gt squared over t, h plus half gt squared over t. Clear? That means vertical velocity component of this guy is equal to the vertical velocity component of this guy. Okay, so these stuff you can directly get when you know. Sometimes it takes time to explain because I need to prove that too. But I know this as a fact. Why? I mean, for them to meet vertically, they should be at the same vertical height, right? That means they should have the same vertical velocity, right? So if they have the same vertical velocity, they would always be parallel like this. Then when their horizontal gap matches, they would meet. So they must have the same vertical velocity. Otherwise, they would not meet, right? Clear? So vertical velocities must be equal. So since now you know this as a fact, now you don't have to go through all this trouble. Just u sine 45 equals root 2u sine theta. Okay? I just have to go through all these troubles because I have to teach you this. Okay? Clear? This vertical component u sine 45, this vertical component root 2u sine theta are equal. Why? See? These two sides are equal. Clear? So sometimes when I'm explaining the question may seem lengthy, but it's not lengthy when you know some facts. Then how can you know facts? That's why it takes time for you to do the paper. Why? Still you don't know enough facts because you don't have done enough questions. When we keep doing questions like this, every day you would gather some facts. Then eventually, even without knowing, your speed would improve. Okay? That's how it happens. Every week in different questions, we gather some facts. Okay? Now this becomes a fact. Now after this, we know this, right? That's how it happens. So these two are equal. Why these two sides are equal? U over root 2 equals root 2u sine theta. Root 2u sine theta. Then u cancels out. I have 1 over root 2 and I'll bring this root 2 here. Again 1 over root 2 equals sine theta. That means sine theta equals what? Sine theta equals 1 over root 2 into 1 over root 2. That means half. Which means theta is 30. Theta is 30. Now the question is straightforward. Why? Now the question is straightforward. Let's apply S equals ut plus half at squared. And in time t, this guy will travel the horizontal distance of x and this guy will travel the horizontal distance of y. So for A, in this direction, u cos 45, starting velocity, u cos 45, and time for the collision is capital T. capital T. There's no horizontal acceleration, so this component is 0. And for B, in this direction, horizontal displacement is y. For B, in this direction, horizontal displacement is y. Velocity is root 2u cos theta. Root 2u cos theta. Time for the collision, again t. Time for the collision is t. And again, horizontal acceleration is 0 for this guy too. So, anyways, x plus y, if they meet, okay, if they meet, x plus y should be equal to this length, u squared over g. X plus y should be equal to this length, which is x plus y is u squared over g, this length, u squared over g, which means x is this, u cos 45 means 1 over root 2 into t plus what is y? Root 2u cos theta. What is cos theta? Theta is 30. Theta is 30. So cos 30 into t equals u squared over g. Equals u squared over g. Now I can solve this. I have u in the answer, okay. 1 u cancels out. 1 u cancels out. Then t over root 2, I can take t out. I can take t out. Then 1 over root 2 plus, here root 2, cos 30 means root 3 over 2. Cos 30 is root 3 over 2. I take t out. So t into 1 over root 2 plus root 2 into cos 30 means root 3 over 2 equals u squared over g. Sorry. Then what is the time? What is the time? This root 2 and this root 2 cancels out and you are left with 1 root 2 here. Then you have t root 3 plus 1 over root 2. Here you have root 3 plus 1 over root 2 equals u squared over g. Then t equals root 2 u squared over root 3 plus 1 g. Root 2 u squared, sorry, root 2 u, right? I cancelled out 1 u, so I don't have a u squared here. This is the answer. Clear? Okay. That's how it works. Okay. That's how it works. So the story is sum of their horizontal distances should be equal to this distance u squared over g. Then only they would collide. Okay. Then only they will collide. Clear? Clear? Go to question 3. Question 3. Question 3. The main scale of a vernier caliper is graduated in 0.5 millimeter divisions. 49 divisions of the main scale coincide with 50 divisions on the vernier scale. The possible reading when the measuring the thickness of an object with this caliper is. So in this case, what is the least count? What is the least count? Question 3. Size of a main scale division 0.5 millimeter. Size of a main scale division 0.5 millimeters. You divide it by 50. You divide it by 50. Size of a main scale division is 0.5 millimeters. And you divide it by 50 divisions in the vernier scale, which gives 0.01 millimeters. That means 0.001 centimeters. 0.001 centimeters. Pay attention, everyone. Now the question is, many answers are possible, right? Many answers are possible. Why? First one, second one, third one, a lot of answers are possible. I can remove some answers. Fourth one is impossible. Fourth one is impossible. Why? Pay attention. 12.62. This is wrong. If it is from this one, it should be 620, right? If it is from this instrument, you should write it as 620, right? So this is not possible. And answer 5 is not possible. Why? It is 22 point something. Usually, vernier calipers are not, doesn't have a length like this. Usually, length of a vernier caliper is around 15 centimeters, okay? Usually, length of a vernier caliper is around 15 centimeters. A 22 centimeter vernier caliper means a huge vernier caliper. You usually don't have these kind of calipers in the lab. Clear? Clear? Length of a vernier caliper is around 15. Clear? So this is impossible. Then, other answers are possible, right? No, third one is also impossible. Third one, it is 9.3240. You can measure only up to third decimal point. This one have 4 decimal points. Clear? You can measure only up to 3 decimal points. This one have 4 decimal points. So this is impossible. And you have 2 answers left. Clear? You have 2 answers left. First one, 0.427. 0.427 centimeters. This is possible. And 2.502 centimeters. 2.502 centimeters. This is possible. Clear? Now, again in A levels, what they ask is the best possible answer. So when they mention something like possible reading, when they ask something like possible reading, there are 2 criteria that it should meet. One is it should be okay with the highest reading of the measuring instrument and the least count. See, we can remove all 3 answers because it goes against with the least count or the largest reading of the instrument. But these 2 are correct. Clear? When you have correct readings, okay, now there are readings that we choose as correct readings and there are readings that we do not choose as correct readings. What is that criteria? It should meet a 1% percentage error. Clear? It should meet a 1% percentage error. That means there are possible readings. There are possible readings. If you have only one possible reading, then that is the answer. Pay attention. If you have multiple possible readings, pay attention everyone. If you have multiple possible readings, clear? If you have multiple possible readings, now you need a criteria to choose between what measurements you choose as correct. That is that 1% percentage error. Can you remember? So, for a measurement to be considered as correct, it should fulfill a 1% percentage error at least. Clear? So 1% percentage error means least count is 0.001 and reading is R into 100%. Again, pay attention. If both answers fulfill that too, okay? If both answers fulfill that too, then both are correct, okay? Then both are correct, definitely. Clear? That is the condition. I'm just checking all the conditions. If there are multiple answers that fulfill both, then I have to give marks for both, okay? Okay. So then I can take reading equals 0.001 into 100, which means 0.1 centimeters, right? 0.1 centimeters. So the first one is 0.427 centimeters. Second one is 2.502 centimeters. 2.502 centimeters. So both meet the criteria, right? Both meet the criteria, right? Yeah. Then I have to give answers for both, okay? Then I have to give answers for both. You should get marks for that. I just checked all the criterias and there are two answers that fulfill the both criterias. I mean, I can't tell now since this is large, so this is the best answer. I can't tell that, okay? I don't have the right to do that. I think that's what we have done when we were marking the paper. But I can come up with such a conclusion, okay? I can't tell, okay, this is larger than this, so this could happen. I can't tell that. Both answers are correct, right? 0.427 and 2.502. Least count, maximum value, and 1% percentage error requirement is 0.1 centimeters. This is 0.4. Both should be correct, right? So both answers should be correct in that scenario, okay? Both answers should be correct. You should get marks. I can't tell that this is the best answer due to that reason or this reason. Can't I do one more question? Anyways, I usually discuss the remaining questions in this paper as a recording, okay? But pay attention. I'll do one more and yeah, I saw it too in lot of scenarios, but that's not that difficult, okay? It is not difficult. I'll quickly go through that. Anyways, pay attention. For question 15 and some other questions, I would provide a recording, okay? Because 15 I can't discuss now. I need at least half an hour to discuss 15, okay? I need at least half an hour to discuss 15 properly. So the people who got answers, like, we'll discuss it later. So, I mean, if you have half an hour, I can start 15. Don't you have half an hour? No. 8. I mean, you're not going to do anything useful after going home, right? So what is the point of finishing the class as soon as possible? Question 8. Question 8. Acceleration time graph for the moving object is given below. The corresponding velocity time graphs. Pay attention. Pay attention. So you have an acceleration. You have an acceleration. Pay attention. You have an acceleration. That means velocity increases. Velocity increases. Velocity increases. Now acceleration is zero. Acceleration is zero. That means velocity will not change. Velocity will not change. Now again you have an acceleration. That means velocity will increase. That's all. Isn't this the given answer? No? Okay. Between fourth and fifth one, definitely this gradient should be larger than this gradient. This gradient should be larger than this gradient. Why? This acceleration is larger than this one. Clear? So fifth one is impossible. Fifth one, this one has a higher gradient. It's impossible because the acceleration here is higher. Clear? Acceleration here is lower. So this gradient should be lower. Acceleration here is higher. So this gradient is higher. Clear? So mechanics from beginning sessions would happen on this Sunday as usual. Not Sunday, right? Yeah, Sunday today, right? No, today is Thursday, right? Yeah, Sunday. Yeah, mechanics from beginning would happen next Sunday as usual. And I would provide a recording for the remaining questions as usual. And tomorrow I'm not sure whether I would be able to do the discussion. If not, I would do a term test paper discussion next Tuesday. Thank you.